going to start the next block. The next block of material. Okay. Can I have your attention? Okay. We are going to start the next block of material, and just like the first block, today and maybe another day we are going to do some review of micro that you will use again for the next block, and then once again we will move on to healthcare. Now, this block of micro is going to be about things from the supplier side. So, we talked about the market in general, we talked about what is demand, what is supply, how does demand and supply interact in the market, how is the equilibrium determined, and then if demand and supply change, what happens to equilibrium, price and quantity. Okay? So, that was like a general overview. Now, what we are going to do is we are going to talk about, in today's class, we are going to talk about production. Any other marker you have, Nate? So, this is once again today's class is purely microeconomics. Okay? This is not healthcare economics, but once again this part we will use the market theory and we will use the market theory and we will use the production and cost theory for in the healthcare markets, and specifically different kinds of healthcare markets. Okay? So, we need to kind of review a little bit. Now, in the production model, when we talk about production, there are two things that are important here. Output. Output is anything that the producer produces, and input. Input is whatever is used to produce the output. Okay? So, you use the inputs to produce the output, correct? So, if you remember on day 1 of this course, we said there are 4 kinds of inputs or resources. Another word for input is also resources. So, there are 4 kinds of resources or inputs, that is land, labor, capital and organization. But if you remember, we said that for simplicity, we just consider labor and capital because we club land and organization under capital, right. So, we consider 2 kinds of inputs, labor, which is denoted by capital L, that is labor, and we consider capital, which is denoted by capital K, not a capital C. Okay. So, labor is capital L and capital is capital K. Those are the 2 inputs which is used to produce the output, and output is usually denoted as capital Y. Okay. So, if I am producing bread, let us say, then my input in this case will be, you know, in the bakery, whatever machines I use, whatever factory setup I have, all that will be under capital. The other inputs, for example, if I am using any flour or whatever, the materials, that will also be considered under capital. Labor will only be the workers hired. Labor is just human resource, always, please remember. Okay? So, a production function is written in the mathematical form as Y is a function of labor and capital. Okay. That means you use some amount of labor and some amount of capital to produce a certain amount of the output. And if you change the amount of labor and capital, then your Y will also change accordingly. Okay, that is what it means. Now, in economics, higher order economics, graduate courses, if I would have done, you know, if I would have taught econ majors the same course, then we would take some specific mathematical forms for this production function, as in we would take different mathematical equations or different mathematical functions for the production function. Okay. But in this class, we are not going into the math because we are just interested in more the intuition. So, we will not do any specific kind of production function, but for your knowledge, it is enough to know that the production function is a certain combination of the inputs to produce a certain fixed amount of the output. And if you change the combination of the inputs, then that fixed amount of the output will also change accordingly. Is that clear?
Can you say that again?
So, the production function is a combination of the inputs to produce a certain fixed output. and if you vary the combination, if you change the combination of the inputs, then the fixed output will also change accordingly. Okay. Now, based on this, different industries, different producers can have different kinds of production function, in the sense that somebody may choose to use more labor and may have a more labor intensive production process. Somebody may use more capital and may have a more capital intensive production process. That depends on the choice of the producer. Now, in a developed country like United States, you usually see that it is more capital intensive, there is more use of machines, right. However, in less developed countries which has more human resource, large population, they would mostly use, labor intensive kind of production process. Now, within the same country, if you think of United States, and we don't bring any other country into the picture, in United States, different industries could be labor intensive or capital intensive, right. For example, in healthcare is a very classic case. It's a very unique case, because if you think about healthcare, while you need capital, while you need modern machines, you also need a lot of manpower, human resource. You cannot operate machines just by themselves. You need doctors, you need nurses, right, to use those machines. You need technicians, lab assistants. So, while you need technological advancement, you also need manpower. So, healthcare in that sense is a very unique market or unique industry where you need a appropriate use, or you need appropriate combination of both labor and capital as inputs. Okay, is that clear? Now, within the healthcare field, there may be certain areas where capital concentration can be more, and there can be certain areas where the labor concentration is more. That is fine. But in general, if we talk, then for healthcare you need both these inputs, and you need a appropriate combination of the two. Okay. Now, in the production process, or in this function, there can be we can divide time period, that means the time over which production takes place. We can divide that time period into two categories. One is called the short run, the other is called the long run. Long run is the more realistic situation. Okay. And this is not divided, these two categories are not divided based on time. It is not like 6 months is short run and 1 year is long run, or 5 years is short run and 15 years is long run. So, this is not a division based on time, rather it is a division based on how you combine these inputs. Okay. So, short run is a period of time when your labor is the variable input and capital is the fixed input. Please write that down. That bar means capital is constant, and I will tell you what I mean by that. Short run is any period of time. It could be 6 months, 1 year, 10 years, 5 years, whatever. It's a time when in the business you are changing the hiring, you are changing how many workers are working, but you are not making any changes to machines. You are not making any changes on the capital side. Capital is constant. So, if you start with 2 machines, you still have those same 2 machines, but you change the number of workers. Okay? That is short run. Long run is when both are variable. That means you make changes to labor, you make changes to hiring, number hired, and you also make changes on capital. Okay? And you understand that is definitely going to be more realistic, because while you can change as a producer, if you were running a business, while you can change your number of employees, you also need to make changes in capital. Even if you don't add machines, remember the concept of capital good. Any capital is which can be improved, which depreciates and hence needs maintenance, remember. So, that is also a change. So, change does not necessarily mean that you add more machines or some machines become redundant. That is not just change. Change is basically anything that you do to your machine. So, repair, maintenance, improvement, all that is also change to capital. Okay. So, I can have the same 2 machines, but every year I am making some repair or on the machine, or every year my machine is wearing out and becoming less efficient. That is also a change in the capital. So, it would qualify under long run. Okay. So, this is the more realistic situation that we have in any production process. You use two variable inputs. What do I mean by variable input? Variable input just means that their amount of the two inputs in the production process can change, and fixed input means that the amount remains fixed, no change whatsoever. Okay? That is what it is. Now, moving on. Now, first we are going to talk about how this affects, what is the characteristics of these inputs. So, we are going to talk about how do these inputs behave in the production process, and once we know the behavior of these inputs, how these inputs behave in the production process, then we will talk about how it affects the output, and in turn how the output affects the revenue and the profit of a producer. That is what we are going to talk about here. Okay? So, starting from the characteristics of inputs. This output that is right here, the output that is produced, the total output that is produced in any business is sometimes also called the total product, TP. It just means Y, the total output that is produced in a business, that is TP, total product. Total product is synonymous to total output. Okay, so you can understand, yes, Casey.
Did you say characteristics of inputs or outputs?
Input, input. So, we are going to look into the characteristics of input, see how those characteristics affects the total output, and then we will see how that goes on to affect revenue and profit. Okay, that is what we are going to do. So, total product is total output. So, you can understand that the total output will be produced by some combination of labor and capital, that is what we have just been talking about. Okay. So, this total product we can say depends on, it is a function of labor and capital, because we are just replacing Y by TP, right. It just means the total output depends on how much labor and how much capital you use. Okay. Now, talking about labor and capital, we must know two things. Okay. First, let us say the total product in this case is, I use 5 units of labor, let us say I use 5 units of labor. Okay, let me write it in a better way. Let us say labor is equal to 5 units, capital is equal to 10 units. So, basically my total product is labor plus capital in a very simple form. It can be different mathematical forms, it can be labor times capital, we can use different forms, but I am just taking the simple thing, okay, that you use 5 labor and you use 10 capital, you combine them, that gives you the total product. Okay. So, what I am trying to say is this total product will be 5 units of this labor plus 10 units of this capital, and that will give me some number. Okay. And that number is not essentially 10, is not essentially 15. That is what I am trying to tell you. Okay. It just means that you are using 5 units of one input and you are using 10 units of the other input, and that will give you some fixed number of total output. Now, the next part is we need to know, okay, fine, we combine this labor and capital, but is it always, so let us say you have a business and you use 10 workers and you use 5 machines, and she has a business, she uses the reverse, she uses 5 workers and she uses 10 machines. Does that mean that the two of you should have the same output, or does it mean that since she is using more machines, she will have more output? Or does it mean that anybody who uses less labor than you will have more output, or somebody who uses more machines will have more output? I mean, what does it signify? Okay, it depends on the productivity of these inputs. It means how productive those inputs are. In other words, productivity is how efficiently are these inputs contributing to the output. Okay. Now, I may have 2 workers, but those 2 workers are extremely productive workers. and you may have 10 workers, but they are not productive. They are, both of them are supposed to work 8 hours. My workers work, these two work for 8 hours each with no break. So they put in 16 hours of work. You have 5 workers, but you know, they are mostly taking a break. They are smoking, they are doing this, they are doing that, you know, eating, chatting, and probably combined they are not putting in 16 hours, 5 of them. Possible, right? So it depends on the productivity of the input. In other words, how efficiently these inputs are used in the production process. Okay? That brings us to two concepts. Basically one concept, but I am saying two because one in terms of labor, other in terms of capital. That is called marginal productivity, MP. So once again we are back to marginal. Marginal productivity, MP, and you could have MPL, which is the marginal productivity of labor, and you could have MPK, which is the marginal productivity of capital. Okay. So what is the definition of marginal productivity? Be it labor or capital, the definition is the same. The marginal productivity of an input means if you hire one additional unit of the input, then by how much will your total product change? If you use one additional unit of that input, by how much will your total product change? Okay. Huh? Capital. Okay. So that means if I am talking about MPL, that is the marginal productivity of labor, then marginal productivity of labor is the change in total product, where in economics we denote change by that symbol, small triangle, which is called delta. Okay. That triangle delta just means change. You could write change also in words, doesn't matter. It's the change in total product for every unit change in labor. It is how much will your output change if you hire one worker. So let's say today you are hiring, and listen to this example before writing. So let's say today I hire 5 workers and I am able to produce 100 shirts. So 5 workers use whatever number of machines and they produce 100 shirts. Tomorrow I hire one extra worker, that is I bring in the 6th worker. When I bring in the 6th worker, obviously the 6th worker, unless the worker is sitting idle, if the worker is putting in some work, then the worker will be producing something extra. So obviously my total will go up, it will be over 100, correct? Let's say it goes to 102. Then the productivity of just that 6th worker is those 2 shirts. So please note that this is the same concept as total utility and marginal utility, where total will always increase as you consume more of the commodity, but the marginal will be going down as you keep consuming more. That means the contribution of every additional unit decreases, correct? Same thing here, same concept, absolutely. Here we are saying if you keep hiring more workers, irrespective of what is happening to capital, let's say, then your total product will definitely increase. Those workers will contribute something to the total output, but what each additional worker brings to the table will go down over time. Okay? So that means this marginal product of labor has diminishing returns. Utility is not here, right? We are not looking at consumption, but the same concept. So we don't call it LDMU, but it's exactly the same concept. You could call it LDMR maybe, law of diminishing marginal returns. So every labor is returning, every additional labor is returning less and less and less to the production process. Okay, where return is what the labor brings to the table, basically, how much the labor contributes to the output. Now there could be different reasons for why your productivity of your labor would go down over time. The reason being, some reasons are, the very basic reason is usually when you have a business, and this is a very real world thing, it's easier to hire people than bring in new machines, because capital intensive production is usually more costly than labor intensive production. That is precisely the reason why poorer countries have labor intensive production, because they cannot afford more machines. So they rather hire workers than, bring in advanced technology or bring in more machines. So that means for any business owner, it is always easier to hire manpower than have machines. And if you look in the real world, always the hiring of workers is faster and higher than the use of machines. So if you have a business, you will probably grow in terms of number of employees much more than your degree of mechanization. That's usually true. For any business, it's usually true. If you open a hospital, right, you start with 5 machines, very costly machines, and you start with 2 doctors. It's easier for you to grow in the number of doctors and nurses than bring in 5 extra machines. Do you see what I'm saying? Because the capital is always the more expensive input. That's why that brings me to the next part, that is, usually there will be a situation in businesses where this labor is variable, that means this labor is growing, but this capital is kind of constant. If we are thinking of a very short period of time, remember short run? So we are basically talking about short run here. Usually you will see in every business that is true. When you start a business, you start with a certain stock of capital and you start with a certain amount of labor. It's easier for you to hire more workers, but it's not so easy to keep increasing the number of capital in the same proportion. So I bring in 1 extra worker tomorrow does not mean I will bring in 1 extra machine tomorrow. It will probably take me 10 years to buy another new machine. Do you see? Okay? Because labor is usually the cheaper input. Okay, so that means we are considering that capital is fixed and labor is variable, given that if I have more workers, it means that those workers are sharing that fixed number of capital. If capital is not increasing and without any change in the capital, I increase the number of workers, it simply means that those increased number of workers now start sharing those machines. So obviously their productivity will be less. If I have 2 workers today and I have 2 machines, those 2 workers will be operating the 2 machines. So each worker has 1 machine to operate. Tomorrow I bring in 2 more workers. Now 4 workers are sharing 2 machines. So each worker is having basically half a machine. I bring in, another 5 workers. So now I have 9 workers but still 2 machines. So it is 2 divided by 9. So every time I bring in workers, and there is no significant change in capital, it means that the productivity of every additional worker is actually going down. That's why for an efficient production process, it is necessary that while you grow in terms of labor, there is a proportionate change in capital. Otherwise, no business will be very successful, because you will hire, but those will be, less productive people. If you have a hospital, there is no good machinery, only efficient doctors and nurses. What good are they without, the other accessories? Because they have to work in combination. Do you see what I'm saying? Okay. So now let's concentrate on this, the economics part for today, not talk too much about examples today. So MPL has diminishing returns, and similarly, if you think in terms of the capital, if labor was fixed and capital was changing, you would still have diminishing returns for the marginal productivity of capital. That means MPK would also have diminishing returns. If you were not changing the number of workers and you would just bringing in machines, then the machines would be sitting idle, some of the machines, because there would be no workers to operate those machines.
So generally speaking, no matter what, you have diminishing returns.
For inputs, yes. Okay, is that clear? Okay. Now let us next talk about one more concept before we look at the, what is the time? Before we look at the relationship between the 3. Now besides marginal product, there can be another thing which is called the average product, and similarly you can have the average product of labor and you can have average product of capital, where average product of labor and average product of capital basically means simply what an average means. It means the total product. So if I am looking at AVL, that is average product of labor, it just means your total output divided by the number of labor that you are using. How much is basically one labor producing? That is what average means. If you have 20 students in the class and the total score is 200, then the average score is 200 divided by 20. If you have produced 100 shirts and you have used 10 workers, then what is the average produced by each worker? It's 100 divided by 10. That same concept. Okay. So, the average product of labor is the total that you have produced divided by the number of workers used. Similarly, the average product of capital will be the total product or the total output produced divided by the number of units of capital, as in number of machines that has been used. Okay. So, now we have three things on the board. We have total product, which is total output, which has been produced by using some amount of labor and some amount of capital. Then we have the next thing, which is average product, which means the total output divided by the number of labor or the number of capital. And the third thing is marginal product, which is basically how much will an additional worker or an additional unit of capital contribute to my total output. Okay. Now, the next thing that we will look at is what is the relationship between these three. Please draw this diagram and do not draw them one beside the other. Please draw one below the other. So, I have two panels in this diagram. In the upper panel, I am measuring the number of units of labor used in the horizontal axis. In the vertical axis, I am just measuring total product or total output. And in the panel below, I am just measuring labor once again in the horizontal axis, and I am measuring marginal productivity of labor and average productivity of labor in the vertical axis. So, the horizontal axis is basically measuring the same thing, which means number of workers. This L is nothing but number of workers hired. Same thing, correct? Here TP just means the total output.
Do you mean AV instead of AP?
Huh? What?
AV instead of AP on the vertical?
On the vertical axis, average product of labor and marginal product of labor. APL and MPL. Okay. Any question you have?
You said AV earlier.
Oh, did I say AV?
Yeah.
Oh, sorry, it's AP, average product. Sorry, average product. It's not AV, average product of labor. Okay. So, it's still number of workers in the lower panel also on the horizontal axis. L basically means the same thing on both sides. Now, so what we are trying to see is if you hire more workers, what will happen to your total product? If you hire more workers, what will happen to your marginal product? And while something happens to your marginal product, how does your total product change? That is what we are going to look at. So, in just the upper panel, we will see that if you hire more workers, what will happen to your total output? Not so simple. Very good. See, you are getting economics so fast now. And then and if you hire more workers, then what will happen to their productivity? And if something happens to their productivity, then what happens to their total productivity? Exactly what he said. Okay. So, let us start with the first panel. So, if you keep hiring more workers, obviously you will see a rise in the total productivity, a steep rise in the total productivity, because you are starting a new business, you are bringing in more and more workers. But one more thing I have forgotten. So here we are considering a very simple case where let us assume that we are only changing the number of workers and we are keeping the number of machines fixed, just for simplicity, okay, because we are just dealing with labor here. I could do L and K here also, okay, it would be the same basically, but let's just concentrate on one. I could do either just K, or I could do L and K, or I could do just L. So I am doing just L.
They would both have to be variable though, not constant.
Correct, yes. Okay. So if the number of workers is increasing initially, then you would see there is an increase in the number of, in the total product obviously, you are hiring more people. As far as marginal product is concerned, please note that when you start a new business and you have a fixed number of capital, that is fixed number of machines, so you have 2 machines and you have 1 worker, the first worker, what do you think will be the productivity of that worker? Very high, right? Because he is 1 worker and he is operating 2 machines. So initially, as you hire more workers, the marginal productivity also rises steeply. There is a steep rise in the marginal productivity also as you hire the first few units of labor.
How come it didn't start in the corner? How come it didn't start in the corner?
It can start in the corner. It can start here at 0. It should start here because I am starting it at 1 because 0 worker is nothing. Okay. So marginal productivity is also increasing. We are not talking about the average yet. Now, please note that at some point, if you keep the number of machines fixed, just as I was discussing, if you are not changing the number of machines at all, at some point there will be diminishing returns setting in, right? So that marginal productivity will no longer rise, instead that marginal productivity would start falling. Do you agree? And that is due to diminishing MPL, diminishing returns.
On the equipment or the
Huh?
due to the depreciation?
Due to diminishing returns. Remember what did I say? That the productivity of the workers falls over time. If I have 2 workers and 1 machine, if I have 1 worker and 1 machine, that worker will use that 1 machine and be very productive. Now next day I bring in 2 workers. So now I have 2 workers, 1 machine. So now 2 people are sharing 1 machine, so each one has half a machine, so less productive. Now I bring in a 3rd worker, the 3rd worker also joins and works on the same machine, so the 3rd worker will be even less productive. 4th worker is even less productive.
I guess I just envision more of a plateau effect than a
Huh?
one guy's working the shovel and there's 5 folks.
What, Keaton?
I guess I just envision more of a plateau that would happen, not a drop.
Can be a plateau, but we are just thinking simple way. Actually it will look like that shape, okay, in the real world. But we are just here, I am just, if that makes you happy, I will draw it that way. I am not drawing the plateau for a reason, okay. And I am not drawing the plateau because of a reason, you will see in a minute, okay. So the idea is that when you have some workers, when you start off hiring with hiring process, those initial workers, those first units of labor, they will be bringing with them productivity, high productivity, because they will have enough capital to work on, they will have enough machines to work on, right. But eventually if you keep increasing just the number of workers and you do not increase the number of machines, then there will be a point that those workers have to share those machines and hence their productivity will be dropping, correct. But before dropping, please note that there will be a peak of productivity. There will be one unique peak of productivity that is also called the peak of marginal productivity, peak MPL. What does that mean? That means at that point, you know, each worker is working at its maximum potential, and after that maximum potential, if you still keep increasing the number of workers without increasing the number of machines, then the productivity of those additional workers will be dropping. Okay. Now, what about total productivity? So, we said total productivity will increase initially and it is sharply increasing. Why is it sharply increasing? Because you are bringing in all these highly productive workers, right? So, that means in this zone where marginal product is rising, total product will also rise sharply. Please write that down. For the first few units of labor where marginal product is sharply increasing, total product will also increase. For the first few units of labor or workers, when marginal product is sharply increasing, the total product will also increase. These are just workers, okay? So that means while you are hiring worker number 1, worker number 2 and worker number 3, those people are extremely productive people and they are also contributing to the total output, but they are contributing in a very highly productive way. That's why the total product is increasing at a very sharp rate, okay? But once after the 4th worker, so when 4 workers are hired, the marginal productivity is at the peak, which means that in this business, given whatever is the number of capital, given whatever is the number of machines, these 4 workers, as long as you hire 4 workers, they are going to be the most productive workers, okay? After the 4th worker, as soon as you bring in the 5th worker without any change in machines, then the 5th worker starts getting less productive, okay?
Like, generally speaking, it doesn't have to be 4.
Yes, generally speaking, just cooking up those numbers, okay? And in that case, do you think total product will increase from the 5th worker? It will still increase, but now that increase will be a flat increase. Do you see what I am saying? It will be a flat increase. Please note that there is a difference in the curvature of this part and that part. The first part, the first section is steep, whereas the next section is flat. Do you agree? So that means in this zone, let's call that zone number 1. In zone number 1, total product is not only increasing, but it is increasing at an increasing rate. That means it is a steep increase. In zone 1, total product is not only increasing, but it is increasing at an increasing rate. That means it is a steep increase. It is a steep increase.
Do you call that peak?
Huh?
Do you give a name for that peak as well? I guess it's not peak, huh?
We have a name coming to that. And please note that zone 1 corresponds to zone A in the marginal product curve, where zone A in the marginal product curve is when the marginal product is also sharply rising, right? In zone 2, total product is still rising, but total product is now not rising as steeply as zone 1. So that means it has flattened out. In other words, total product is increasing at a decreasing rate. Write down, Josh. Total product in zone 2, total product is still increasing, but it is increasing at a decreasing rate. Or in other words, it is flattened out. It is a smoother increase. And please note that zone 2 corresponds to zone B on the marginal product curve, where in zone B, the marginal product is actually decreasing. Or in other words, the diminishing returns to that factor, that diminishing returns to that input labor has set in. Your labor has started becoming less and less productive in that zone, in zone B. Okay,
Meaning like your production per worker.
correct.
Say that, okay, marginal,
Not production per worker. Production per worker would be average. Okay, but I know what you are trying to say. The contribution of every additional worker to the production.
the marginal production is decreasing.
Correct.
Did you say something else?
In zone B.
Oh.
Okay.
It's like you got so many workers that they're getting in each other's way.
Hmm?
It's like they're getting in each other's way.
Yes. Yes, you are getting into each other's way. Okay. Now, please note that this, okay, come back. Now, please note that this point here exactly corresponds to that point there. So, that means this peak corresponds to the point where the curvature of the total product curve is changing from being very steep to somewhat flat. That point is called the inflection point of the total product curve. Inflection point. Where inflection point just means the point where the curvature of the total product curve starts changing.
Point where the what, total production,
Huh?
where the total,
Product starts from going from very steep to somewhat flat. So, it is basically the point where the curvature of the total product curve changes. And why does that curvature change? That curvature changes because the marginal productivity changes, right, from rising to falling. So, the peak of the marginal product curve is the point where it goes from going up to going down, right. So, that peak should be the point which corresponds precisely with the inflection point, correct, because this is where the marginal product starts going down. So, that must be the point exactly where the curvature should change. Is that clear? Yes? Now, please note that if you still keep the number of machines fixed and you still keep increasing the number of workers, will there eventually be a point where this hits 0? That means you bring in workers and some workers, theoretically, is it possible that you bring in some workers and some of those workers do not get a chance to operate machines at all, they are just sitting idle? Their productivity is almost close to 0, right? And after a point, there may even be a theoretical possibility if you are a crazy producer and you still keep, hiring workers without increasing your number of machines, there may be a possibility that those workers start getting harmful to your business. They are a burden on you, right? I still have those 2 machines and I'm just increasing the number of workers, right? There is a limit to how many people can work on a machine. If I'm a crazy person and I just go on increasing the number of workers, there will be a point where the workers have to fight amongst themselves to operate the machines and there will be some workers sitting on the bench. And that happens, trust me. In the IT industry, there are always people in the reserve bench. There are more workers than the available work and the available capital. It is not so much evident in USA because in USA most of the work in the software industry is outsourced. But I have friends working in the software industry in India, they are just getting salary sitting on the bench. They don't work. They are waiting to work. Those are called bench workers. Okay? So, I guess what I'm trying to say is that if there was a production process like this where you don't increase your capital and you keep increasing your labor, then that is not beneficial for you. That is what I'm trying to hit at. You have to increase them in some appropriate proportion. If you just keep increasing one input, then that input will eventually have a diminishing returns, and to the extent that that input will start being not only less productive but negatively productive. That means it will bring harm to your business. It's going to be a burden on your business, right? So what I'm trying to say is that in that zone, so if I can divide this, I can say that let's say this is some zone C. In that zone C, where it is falling and it is hitting 0, the marginal product is hitting 0 and even becoming negative maybe, although you understand that that is not rational in the real world, why would I as a producer bring in workers when they are harmful to my production process? I'm not going to do that, right? But theoretically, if that was the situation, then this is where the total product, instead of increasing anymore, will start falling. Do you see what I am saying? So that brings me to the last point, that theoretically this is possible, but theoretically the producer will stop somewhere here before it goes to 0. So the marginal product curve in effect will not have that C zone, it will stop somewhere there. So that the total product may, be increasing at a decreasing rate, but after that it will kind of flatten out.